So the most obvious thing to do would be starting with the network. Taking a look at our code in our last video, you may remember that we talked about putting together an abstract class so everything that runs could be able to use the same signature in our Trek1 or main game loop. Very promising. Remember that we have an abstract base class module from which we want to import this time, just to show that it can be done, the ABC base as well as the abstract method from the ABC module. So we can create our own class, which is going to be abstract. So we might as well call it abstract run or abstract runner in this case, to base our class upon the ABC template, which will allow us to also create a must-have abstract method that we're going to define as run with our obligatory self. Since we're going to be a class, we're going to have to get our instance, and then we use our kwargs simply because if we don't have any kwargs, we'll get an empty dictionary. If we do, of course, we'll get our dictionary, which is a great way to extend our class, even if we're going to take a pass. And since we have a class, of course, we should always define an init, even if we're not going to do much at this point in time. And that init is simply going to allow us to call the super method so that we can initialize things, much as you see here. Let's go ahead and put a comment in here, simply because it's nice to have some information. And our information will include, let's run a variety of servers, clients, and games, and here's how we could do that. We'll go ahead and reference my video over on O'Reilly Media where we talk about TCP/IP and UDP/IP under Python. There's a nice little number for it if you're interested. And at some point in time, I'll put a reminder in there that I'd like to seriously do some logging as well. And clicking on the link, there's a nice video you might enjoy. Under an hour and a half, but it covers the high points, if not the lion's share, of what you can do with datagrams and sessions using modern Python. Now that we've got our abstract base class, which itself is based upon an abstract base class, let's go ahead and switch over to our main track, also known as PyTrack1. So as to simply implement PyTrack, abs run. And because we already have a .run, even if we don't have a kwargs, obviously going to run, but simply for the sake of clarity, even though it's not required, we'll put kwargs in there as well. Now, I don't have to call this kwargs, and to prove it, we'll simply put in, I don't know, foo, because it doesn't have to be called kwargs. We can call it whatever we want. What is important, however, and as you probably know, are the double stars, which tells me we have a key value pair, and we're going to put it in something called foo. So now that we have an ABS runner, all we have to do is run to see that things work just as we would expect, very seamless. And if we get rid of foo, of course, and save our changes, everything runs, whether we have kwargs or not. Deciding not to make people think, we'll go ahead and call but we have kwargs, but like self, we could name self anything, and we can name kwargs anything. Keeping things expected allows people to quickly understand what we're trying to do. And once again, the goal here is always to be writing self-documenting code. So the next thing we need to do, of course, is to have our abstract server as well as our abstract class so we can run it as we'd expect in our run game loop. Working first with our run client, let's try something simple here, simply by importing our abstract runner, at least trying to, from PyTrack. And if we can't find it, of course, we're going to generate an exception. And if we have an exception, or if the PyTrack package hasn't been installed by Python, of course, we'll then try our little hack, which allows us to give us the best of both worlds. Although it's a little ugly, we could have one code base for research and development and one code base that'll run when people have PyTrack installed on their system path. The next thing to do, of course, will be to create our class to initialize ourselves using UDP. So we'll call it an obvious name, UDP init, extending ABS runner like we just saw us do with our game. So both will have a run method Very simple to do. We do the same thing once again, using an expected set of variable names. Conventions matter a lot. And here's an interesting convention we should talk about as well, noting that every time we have an instance of self, for example, we can have a dunder class. And of course, once we have a dunder class assigned to us, we can inspect the class. We can also take a look at the dunder name, and that will print the name of our class, no matter what instance, in this case UDP init or our server, we're running. Of course, we'll be expanding our run method later on to initialize a UDP with the server from the client. But for now, our test case is simply to create an instance of UDP initializer. That, of course, allows us to first create our instance that will return a value. And Python is smart enough to know that once we return a value, we're going to run the run method. And running that module, we see that we do indeed get our dunder class dunder name. Once again, we'll be expanding this later on to actually broadcast our UDP package out to connect to our server. Using the exact same hack, of course, we're going to go ahead and favor feature over form to import our abstract runner. Once again, creating our game server test, to which we're going to do the exact same thing and do the exact same test. So when we run our module, of course, we see our game server test. So by the miracle of polymorphism, we can now update our main loop. And rather than running the default game as we see here, we can instead check for mode in the keyword arguments. And if we have mode in kwargs, and that mode equals, the client, which is specified, we can do something. Otherwise, we're going to go ahead and check to see if that mode equals server. And if it equals server, of course, we're going to be able to import very locally our run server from our game server test. And then, of course, simply create the game server to override our classic game. Next, if it's a server, the same thing would have to be done. We're going to import run client and the UDP initializer and do the exact same thing. Easy peasy, wonderful stuff, because no matter what we choose to do, there's no fluff. We don't have to do anything more to override our game. A little inefficient, yeah, maybe we're creating the object that we don't need. We're going to get rid of it. But the nice thing is it's much easier to understand rather than having a bunch of different runs and codes and hacks and whacks. And gosh knows, we could just mess this thing up to our heart's content. These days, I don't really care too much about redundant objects. At today's computer speeds, even on embedded devices like ESP32s in my pockets or Pis, I don't mind a little speed, because to tell you the truth, you're not going to tell the difference net to net. Not on a single user, even a multiplayer game. So here again, we're going to focus on looking at the ease of code reading, rather than doing something, for example, like for an exception, if mode is not in kwargs, or simply creating a switch statement where we have cases for mode and default cases. Honestly, this is about as succinct as you're ever going to get. So could we do more? Yes. Should we do more? It's an Obi-Wan kind of point of view way of looking at things. And since I'm teaching and trying to get people to understand default loops, this is adequate for my purposes, and we reserve the right to change it to something a lot more verbose and a tad more efficient later on. So running PyTrek as we'd expect, continuity would demand that he would be able to quit as we expect, or we can do the -H to see our help, in which case we know that we're going to have either a classic, a client, or a server. No big deal. So replace that $H with the $MODE and say client. We see our client, server. We see our server, and even we said classic, we'd see our classic But if we added something interesting, we'll print our error message before running quit, and because it's a command line prompt, we don't get our ending dialog box. We simply quickly quit the program. Setting the stage for what's coming next, of course, we're going to be implementing our UDP client and server in the next video. So take a moment and make it so before moving on to the next video. Ugh, nasty. Well, you do what you can to make it fun, and that's the best I got, son. Hey, a quick note to self for the last example. I wanted to mention that I simply cut and pasted what I had gotten from an AI, and it really wasn't good. To our supported type check, I mentioned that we should return a Boolean. That's not the case. So by way of an explanation, of course, we can indeed do exactly what we saw. We saw it work. When we had a type that wasn't supported, we quit our program. But by returning the type or echoing it back as a string, in this particular instance, we could, for example, take an alias of 100 or 200, any one of our modes, and return the string that we wanted to actually pass into our program. So in addition to editing, we have an opportunity for a macro substitution, if you'd like. And in addition to changing our mode, rather than using, for example, several more options, for example, to pass parameters to our client or our server or even to our classic, we simply went ahead and updated our code to use the mode so as to give us the superior switching of a single mode rather than having a client and a server command line option, which obviously we probably will want to do later on, but we have no need to do at the moment. See you next time.